So this video is going to be talking about how to measure amounts of gases in terms of moles and number of molecules. So it turns out that for a mole of a gas, now gases are compressible, volumes change with temperature, so we're always going to be referring to gases for now at what we call STP, and that's standard temperature and pressure. And STP is 22.4 liters. That's the molar volume. So if you have a mole of any gas, and it doesn't matter what type of gas it is, a mole's worth of the gas molecules will take up a volume of 22.4 liters. And STP is 0 degrees Celsius and 1 atmosphere. Atmosphere is just a unit of pressure that we use, and that's the metric standard. Oftentimes, instead of using 0 degrees Celsius, it'll be given in Kelvin, and that's 273 Kelvin. So the relationship 22.4 liters per mole, or 1 mole is 22.4 liters. So if you have 19.2 liters of hydrogen gas, and in this case they're hydrogen molecules, it's a diatomic element, and it's at STP, to convert to the number of moles, you just simply take what you're given, the 19.2 liters, cancel liters, we want moles, make sure that we're labeling, including the hydrogen. It's going to be important. Some of you have not been doing that, and it's been catching up to you. And then put in that relationship of 1 over 22.4. And then you're just dividing, and you get 0.857 moles of hydrogen. Likewise, if you're given moles, and we want to know how many liters, it's just kind of the opposite. So you start with 3.94 moles, in this case carbon dioxide, and then cancel moles, go to liters, using the relationship of 22.4 liters per mole. Now this also lets us look at gas density. Remember that density is mass over volume, and the mass is the molar mass of the gas. So we're going to be using the mass of 1 mole of whatever the gas is. And then the volume would just be the volume at STP, which we know is 22.4 liters. So if we want to know the gas density of carbon dioxide at STP, well, for mass over volume, first we have to find the mass. So to find the molar mass, again, CO2, so 1 carbon, 2 oxygens, 44.01 grams per mole is the molar mass of carbon dioxide. And then we're just going to take and divide that with the molar volume of 22.4 liters, and we would get 1.96 grams per liter. If we look at ammonia gas, NH3, again, the mass is going to be the molar mass, so 1 nitrogen, 3 hydrogen, gives us a molar mass of 17.04 grams. Density, mass over volume, so 17.04 grams over the 22.4 liters gives us a mass gas density of 0.761 grams per liter. Can also set it up in one step using dimensional analysis. We know that if we have 17.04 grams per mole, let's just set that up as grams over 1 mole. We don't want grams per mole, we want grams per liter. So we're going to cancel moles. We want liters on the bottom, so you put in that relationship. It does the same thing, it's just a different way of looking at it. Gives you the same answer. If you're given the mass density, or the gas density, sorry, and you want to know the molar mass, we can also do that. So if we are given 1.96 grams of an unknown gas, that occupies a volume of 1 liter, and it's at STP. To find the molar mass, basically what we want to do is we want to go from the grams per liter, which is what we have, grams per liter, and we want molar mass, which is grams per mole. So you just set it up as 1.96 grams per 1 liter, and then we want to cancel liters to get moles on the bottom. So you just set that relationship up of the molar volume, 22.4 liters per mole. So 1.96 divided by 1 times 22.4 divided by 1 is 43.9 grams per mole. Next one down, if you're given 13.75 grams of an unknown gas, that's filling a volume of 4.53 liters. Get to the molar mass the same way, just that we're not putting it over 1 here, we're putting it over the 4.53 liters that the 13.75 grams occupies. And then again, canceling liters to get moles on the bottom, and then just calculating across. So just a quick summary. The mole is our central idea here. Mole is Avogadro's number, or 6.02 times 10 to the 23 units, which could be number of atoms or molecules or compounds or formula units. We also know that a mole gives us the molar mass in grams by looking at the periodic table or the chart that I gave you. And then the molar volume is 22.4 liters at STP. Later on, we'll talk about how to deal with temperatures and pressures that are not at STP.